Okay, so today we will talk about the part 3 of the series where we are talking about the PyTorch. So, lesson 3, the part 3 is about autograd. It means automatic differentiation in PyTorch. So, in part 1 and part 2, we were discussing about the basics of PyTorch, what else we can do with the library. Now, here, the main things we will talk about is the differentiation. So in deep learning we need to compute the gradient, right? That is derivative for optimizing the equation like back propagation. So PyTorch autograd system handle this automatically. Now let's understand this autograd. So autograd is nothing but a PyTorch automatic differentiation engine. It keeps track of all the operations on tensors with the required grad equal to true. It means it will if it required underscore grad equal to true, it means it will have a automatic track of the computation whatever it's happening, like automatic gradient computation for back propagation, right? So the and the PyTorch records these operations in a computational graph and calculate gradient whenever needed, right? So the whole neural network concept, whole deep learning concept is based upon the derivation, right? Now the chain rule derivation, back propagation. So to keep track of all those back propagation result for each derivation, what was the compute value, we need something, right? And this is where the autograd comes into the picture from PyTorch. Okay, so let's go through it. So here we can see we are just importing the torch as a library, then we are passing the tensor. So we are actually creating a tensor with a requires grad equal to true so that it will track the computation, and we are inside the tensor we are just passing 2. Then let's say we have a function y is equal to x square, right? So y equal to x into 2, and then we compute the gradient dy by dx. So here we are doing backward, so kind of a back propagation, and then we are printing x dot grad. So this one will give you the result 4, as you can see here. The tensor 4 it's coming because dy by dx, if you remember our basic operation of derivation and differentiation, it's 2x dy by dx. If it is x square, then it becomes 2 comes into the back, then 2x, and while we are passing 2 into the tensor, then 2 into 2 becomes 4. That's the reason we have 4 as a result. Okay, so what are the takeaways in this concept? So if you want to track the computation, you need to put requires grad equal to true. That's the first point. Backward, as I said, compute the gradient automatically. Okay, whenever we call this function backward, it will compute the gradients automatically. And x dot grad stores the computed gradient. Here we are automatically, not automatically, basically when we are calling x dot grad, then it will have the output, the computed gradient output here in x. Okay, now with that, let's go to the next concept. The next concept is nothing but the computing the gradient for vectors. So we were here in the earlier example we were dealing with only one tensor, but what if we need to do a multiple we need to do in vectors? So when we are dealing with multiple outputs, PyTorch need to have a gradient vector, right? Example, a gradient for a vector function, so more than one. So here we can see we are passing a 2 numbers into the tensor, and again required grad equal to true. So the same equation y is equal to x square, and when we are computing y dot backward, so now we are doing it for a vector. So we need to put something like this to compute the gradients. Y dot backward torch dot tensor, we are passing 1 1, just the vector, and then x dot grad. But the answer what we get is 4 and 6 because we have a 2 value, 2 and 3. And if you do dy by dx, you know how does it work, and that's the reason we have 2 output. So as of now we have seen 2 types of things, single numbers and the vectors to compute the gradient. Okay, so using PyTorch we can compute this derivation easily using backward function. Okay, I hope it is clear. Now, what is the key takeaways here? If y is a vector, pass a gradient vector torch dot one likely to the backward. Okay, so if y is a vector, pass a gradient vector. What was the gradient vector we have here? It was 2 and 3 we are passing, and then it is the ones likely for the y to backward. Okay, so the same thing we have done here. Now let's go to the stopping autograd tracking. Sometimes we don't want PyTorch to track the gradient. It is not necessary. For example, during the prediction, during the time of inference, then how do we stop that? There are multiple ways. The first one I have written here is detach. So if you, once the y has the value, and if you put a detach next to the y dot detach, so now PyTorch won't track your y value. Okay, that's the first way. The second way is with torch no grad. If you give no grad, then also it will not have a gradient tracking. Okay, and the third one is temporarily disable. So it's the third way, torch dot set grad enabled. If you put it here, set grad enabled false. If it is false, it is not going to track again. Okay, so key takeaways out of these three way of stopping the gradient tracking is use dot detach or torch dot no grad when gradients are not needed. Example, during inference. Of course, you can use the third one also, but the easiest one I find is detach. Okay, with that, we'll go to the next set of understanding, the next set of concept, computing gradient with for multivariable function. Okay, so as of now we were doing y equal to x square. What if we have something like this? Function of x and y equal to x square plus 3y, right? So multiple variable are there. Then also honestly things does not change much. It just you need to put extra effort, extra writing, extra variable which will cater the two variables, in this case two variables, like x equal to torch dot tensor, here we are passing 2, y equal to torch dot tensor, here we are making 3. Now this is the function f is equal to x square plus 3y, and again we are doing the back propagation using backward, and then we are computing, saving this as a x dot grad where we will have the result. So we got the result 4 and 3. Okay, so this is as simple as the earlier. The only thing is we are just making it a multivariable function, not just a one function like x square. Now here we have x square plus 3y. Okay, then zeroing out gradient. This is the one concept which sometimes we need. So PyTorch accumulates gradient by default, right? So we must manually reset them in the training loop. There are the scenario where you need to reset them to the 0, so that again it goes back to the function and it calculates and store the gradient. Okay, so now for that we need to have a clearing gradients, basically zeroing the gradient. How do we do that? It's simple. We just need to have this as a required grad is equal to true. That would be same, right? But everything remains same. So here we are using for loop because we have to apply a for loop to each point of a y wherever there was a derivation, wherever there was a gradient value accumulated, calculated and stored. You can see here till x dot grad we are accumulating for each x and putting it into y. Now the next step is the x dot grad dot geo. It means it will reset the gradient. It will remove all the gradients which has been stored earlier. Okay, so I hope this one is clear. So again, takeaways is same, using the 0 function before backward in training loops, of course. So with that, these are the assignment you can try. This will help you to understand the PyTorch into the next level. Create a tensor where x equal to 4 with the required grad equal to true. Compute y equal to x to the power 3 plus 2x. So it's a multivariable, and find dy by dx. So now here you can find dy by dx as I explained earlier. Now create two tensors equal to 3 and b equal to 2. Compute again function a and b a to the power 3 plus 4b square. Find df by dA and df by dB. Okay, that's again we are passing two things here, a and b. The third one is to detach the thing which I explained earlier, using detach, or you can use torch.nograd to stop tracking gradient of the tensor. So these are the assignment which will give you a clear-cut understanding of PyTorch in order to do a differentiation derivation and making it tracking the gradient, not tracking the gradient and at the last making the gradient value to the 0, so that again it can accumulate the gradient value. Okay, with this is the third part of PyTorch series which I'm making. If you go through each part in a sequential manner, you can learn this framework, which will be very helpful for your future, especially if you are into AI data science. Okay, thank you so much. See you later. Thank you.